Related rates. Now, related rates typically deals with the derivative with respect to time or how it changes with another derivative. Now, when we do related rates, say we have the equation y equals x squared plus 2. When doing related rates, you use the chain rule like you do in implicit with every variable. So dy dx, and or if this is done with respect to time, it would end up being dy dt equals 2x dx dt. And a lot of times it is used with geometry. So let's say a cube, all edges are expanding from a cube at 8 centimeters per second. So dx dt is let's say let x be the length of one side. So it's expanding at 8 centimeters per second. Now, the area, the derivative of the area, or the volume, dv dt, is gonna change depending on how far we are along the time. So, for example, when the edge is 2 centimeters, well, first we need an equation to find the volume from each side. And since the cube, all sides are the same, a equals x cubed. And from this, right, we find the derivative, or v equals x cubed. Now we find the derivative, so dv dt with respect to time is equal to 3x squared dx dt. And since we're looking for at 2 centimeters, and we know dx dt is 8, dv dt is going to be equal to 3 times 2 squared times 8. Now, it's going to be equal to 3 times 4 times 8, so 12 times 8, which is 96. So dv dt equals 96, and our units centimeters cubed per second. Now, yes, this is centimeters per second. Now, this can also be done with just variables. For example, let's say x squared plus y squared is equal to 25, and dx dt is equal to 7. We want to, and x is equal to 3, and then we want to find dy dt, or dy dt when x is equal to 3. So first we know dx dt. Let's do it right here. Dx dt is equal to 7. We have that. X equals 3. Now we want what y equals. Now, to find what y equals, we simply plug in 3 for x. So 3 squared plus y squared equals 25. 3 squared is 9 plus y squared equals 25. Y squared is equal to 16. Now we square root both sides. Y is equal to square root of 16, which means y is plus or minus 4. Now we have all three, and the only term we need to know is dy dt. So we're going to find the derivative of this, which is 2x plus 2x dx dt plus 2y dy dt equals 0. Okay, now we want to since the dy dt is right here, our goal is to isolate it. So 2y dy dt is equal to negative 2x dx dt. Now we divide by 2y, so dy dt is equal to negative 2x dx dt over 2y. Now, in this case, let's say y is equal to 4. Actually, let's see a solution where we're looking for a positive number. In this case, let's say y is negative 4. So dy dt is equal to negative 2, x is 3, times dx dt, which is 7, over negative, or 2 times y, which is negative 4, and that's going to be equal to 6 times 7, 8, so it's 42 over 8, and which simplifies to 21 over 4. And that is our positive answer. If we plugged in positive 4 for y, it would just be negative 21 for 4, but we're looking for a positive answer in this.